Hello, my name is Chad Varney. I'm an application engineer here at Ally PLM Solutions. I'd like to welcome you to another session of NXCam Lunch Bytes. Today we're going to look at wire cut in NXCam. We have several of you on the line with us today, so you'll be in listen-only mode for the session. If you have any questions after the session, you can email those to me at chad.varney@allyplm.com. I want to remind you that we have all of our Lunch Bytes replays available on our website. You can check those out at www.allyplm.com. We also have a section where you can give us your suggestions for future Lunch Bytes topics. Today we'll be looking at wire cut in NXCam. There are several reasons why you would want to use wire cut. Wire cut can remove a lot of material and areas where maybe you wouldn't want to do milling. You can also do very intricate parts like you see in the picture there. So again, we're going to look at some of the operations and details in NXCam wire cut. So for today's agenda, we're going to look at the no core operation, 2-axis internal trim operation, 2-axis external trim operation, 2-axis open profile, 4-axis internal trim, 4-axis external trim, and 4-axis open profile. Alright, to get started, the first thing we're going to look at is the no core operation. If you don't want to leave a slug in the middle, you can use the no core operation. It's going to basically use the wire to burn out the center of the pocket that you're trying to cut. Keep in mind this is only available in 2-axis. So if you're trying to do a 4-axis type part, this operation is not going to be available. So what we're going to do first is this cutout or pocket right here. And again, we're going to use the no core operation. I'm going to first define the workpiece. And then go ahead and create an operation. Under type, I'm just going to use the Wire EDM option. So the first option that we're going to look at here is no core, and as you can see there, removes all the material inside of a closed area with a series of offset paths, leaving no slug. Again, available 2-axis only. So the first thing I'm going to do is specify the Wire EDM geometry. In this case, I really only have 3 options for picking geometry: a face, a curve, or a point boundary. For this option, I'm going to use curve, and I'm just going to simply select the curves. I'm going to go ahead and specify a tool. I'm going to use a 0.5 tool for the demonstration today, just so that you can see it a little bit on the screen. All right, we're going to accept most of the defaults here and then kind of take a look at some of the details as we go. We're going to leave the default FollowPeripheral, and we'll go into the cutting parameters. Notice we have an upper and a lower plane. We need to set the upper and lower plane based on the thickness of the part. I'll go ahead and measure the thickness of this part. It is 30 millimeters, so my upper plane needs to be set at 30 millimeters. Our upper and lower guide offsets are set to 1 millimeter. We'll leave that, that's fine. And then we have a wire position on or tangent to. I'm going to go ahead and use tangent to. Now our step over values, it's set to a percentage of the wire diameter, 60% of the wire diameter in this case. We'll go ahead and leave that and then accept the default tolerance settings. All right, so the first thing we need to look at is the FollowPeripheral option. It starts in the middle and works its way out towards the outer perimeter of the feature. Now, one thing that we didn't tell it is where the start location is. It automatically just picked a start location. What we can do is specify the start location. I can go back into the boundary, use control points, and specify our thread hole location. So I'm going to go ahead and specify that at the center and go ahead and generate. So now it is specified directly in the center of this arc. The other thing that we should look at is the spiral option under cut pattern. I'm going to go ahead and change this and show you what it looks like. It starts at the center and then spirals outward. Now the only thing about this in this situation is we have these kind of jagged edges there, so that may not be desired. So you may want to use FollowPeripheral in an example like this. And then the next thing that we can do is specify inner boundary. For example, maybe we already have a hole in here, like a starter hole. We don't want to waste all the time to cut out those little step overs with this little wire. So we can define that inner boundary. So to define the inner boundary, I'm going to actually just insert a curve, basically a circle curve. So I'll just draw a curve at the center point. And give it a radius of about 6 millimeters. So now we see our curve. Now I'll just go back into the operation. And again, I can specify inner boundary. And then just simply select the circle and generate that. Now we're still starting from the center, but we are starting from the center of the hole, and then we're removing all of that extra cutting to save you a little bit of time there. All right, the next option that we're going to look at is the internal trim. And this part is all 2-axis. You can see there's no taper or anything on this part, so everything that we're going to do on this part is 2-axis. So we're going to use the 2-axis internal trim for this pocket here. Go ahead and create an operation and use internal trim. I can go ahead and use the same tool that I used on the previous operation. Now I'm going to specify wire geometry. Since we're doing 2-axis, the options for picking geometry are the same. So I'm going to go ahead and use curve. Now I can pick each of these curves individually. Wouldn't take too long in this part, but you can imagine if you have a part that's got multiple, curves that you would have to pick, it may take a while. So I would suggest using chaining. So I'm going to turn on chaining, and if you haven't used chaining before, I'll go ahead and kind of describe how this works. For chaining, it depends on which side of the edge that you pick on. For example, if I pick on this left side of the line, that's the way the chaining operation is going to go. If I were to pick on the right side, the chaining operation is going to go around this way. So I'm going to pick on the left side of the line, and then NX is going to basically follow all the way around to wherever I pick next. So I'll just simply pick here, and then it chains all the way around for me. So again, it matters on which side of the line you pick on. So that looks good. Now for now, I'm going to set the rough passes to 0. We're not going to take any rough passes, and we're just going to do one finish pass on this part. We'll look at backburn distance here in just a minute. In cutting parameters, again, we need to set the upper plane, which was 30. Upper and lower guide is a millimeter, that's fine. We're going to do alternate directions, and actually, since we're just doing one roughing pass, or one finish pass, this won't won't matter. So we could either do clockwise or counterclockwise. So you can select these, especially when you're doing roughing passes, and determine which way you want your cut direction. In this case, it actually doesn't really matter. So now overlap distance. When this wire cuts all the way around this outer shape, if it starts and stops in the exact same location, you have a chance of leaving like a little edge or a piece of material sticking out. So we can set an overlap distance. I'm going to go ahead and set that at about 3 millimeters, and then we'll take a look at it after this generates. We're going to do wire position tangent 2, and step over shouldn't matter in this case either. We'll go ahead and generate this operation. Now notice NX automatically just picks the start location or the lead in and lead out points, and it happens to pick right here. That may be fine, but if you want to set it at a certain location, you can still do that as well. Notice the gap between here. One is the lead in, one is the lead out, and the gap between is the overlap distance. So we'll go ahead and take a look at this in verification. Notice it's leading in here, and then it works its way around the part. Gets back to here, and again overlaps so that you don't have that extra piece of material left when you're done, and then does its lead out. So now we're going to look at doing a lead in over in this corner. So I'll go back into internal trim. To do that, I need to go back into my wire geometry and go to control points. Control points, you have a lot of options here. A thread hole point, lead in point, retract point, tab points. So what we'll do is I'll go ahead and add in just a lead in point for now. So I want my lead in point to be centered on this edge. Go ahead and accept that and generate. So now notice that my lead in is directly centered on this edge. Now to specify a start hole location or a thread hole location, we use the same options here in control points, and then we'll just pick a point. So I'm going to use thread hole point, point option. I'm going to specify. I'm just going to bring up the point dialog and click somewhere close in here. In a real scenario, you would have a hole there, and I'm sure know the position of that. So for this example, I'm just going to go ahead and use 50 in X and 42 in Y. And we're going to assume that that block has a hole there for our wire thread location. All right, we'll generate that. So notice it comes from here over to the lead in and then starts the wire cut operation. I'm going to go back into cutting parameters and change this overlap distance to 0. And why I did that is so that we can see what this backburn distance does. So for example, maybe I want multiple roughing passes on this part, and I want to leave a little tab here basically to hold this slug in place. So if I do multiple rough operations, I'm going to go ahead and put 3 in here. My backburn distance is the length of tab that it's going to leave. So I'm going to go ahead and use a millimeter just so we can kind of see it, and then I'm going to go ahead and change that to a bigger amount, let's say 6 millimeters. So now you can see that it's leaving a tab. So it does its rough cuts, leaving this tab connected, and then when it goes to do the finish cuts, it cuts this tab off. We can also add in multiple tab locations. For example, we can have a tab here, and then maybe a tab over here on the right side. We do that by going into control points again and adding in a tab point. The method we're going to use is a point and a tab width. So I'm going to specify a point. I'm going to go ahead and just select the center of this edge. And then the tab width, just to make it match the other side, I'll do 6 millimeters. And we'll generate that. So now notice we have basically a gap or a tab here on the left side, and then also a tab here on the right side. So again, that's just a way to hold the part in place until the finish cut. All right, so now let's take a look at external trim. We're going to first cut all the way around the outside of this part. Again, this is a 2-axis part, so we use the 2-axis external trim operation. So we use external trim. We use the same tool, and we'll go ahead and specify our geometry. Nothing really different here on specifying geometry. I'm going to use chain again, and I'm going to pick the left side of that edge, and NX will chain all the way around there for me. And like we did before, I'm going to go ahead and just specify 0 rough passes and 1 finish pass. And we'll need to input this upper plane again. And we'll go ahead and generate. So again, NX automatically picks the lead in and lead out location. So if we want that to be in a different location, we can do the same thing. This works the same way as internal trim by going to control points and then specifying a lead in point. So maybe we want the lead in over here on this edge, and we'll go ahead and generate that. Now this also leaves a tab. The default was 1 millimeter. So if we needed to leave an extra amount there, we could type in whatever distance, and it will change that value. If we don't want anything, we can do just 0 here. There is also a couple other options and non-cutting moves for our engage type. We can select lead in. Notice it's set to direct. We can specify an angular lead in. For example, maybe we want this to come in maybe at a 45-degree angle. So now we're leading in and leading out on a 45-degree angle. The lead out is set to the same as lead in. And then we also have an option for a circular lead in as well. So we'll do an arc radius of, let's say, 4 millimeters. So now we have an arc coming in. All right, now we'll take a look at the open profile option. So for example, maybe the outside of this block is already cut, and all we need to do is do this cutout shape here. We'll use the open profile for that. So I'll create an operation, open profile, and we'll go ahead and select our geometry. This is 2-axis as well. And I'll go ahead and I'll use chaining again. So I'll pick the right side of this edge, and I want it to finish up over here. Okay, so the start and then the finish. And I'll go ahead and leave rough passes and finish passes at the default. And there we see the operation. So we see it is doing 1 rough pass and then 3 finish passes. So the only difference between open profile and external trim is the fact that this profile is an open profile instead of a closed. It's not completely closed. And then we have the same options available that we did in external and internal trim as far as lead ins, lead outs, things like that. Okay, so now we'll go ahead and close this part out, and we'll take a look at another part that is going to require 4-axis. As you can see in this part here, all of the walls on this internal profile have taper. So this is going to require 4-axis wire EDM. So I'll go ahead and specify the part. And go ahead and get started creating the operation. This is going to be an internal trim operation. And I'm going to need to specify the wire geometry. Notice I have a toggle back and forth between 2-axis and 4-axis. I'm going to need to select 4-axis. A couple options that we have here. We have a top face option and then a wireframe option for geometry selection. I'm going to go ahead and use side faces. So now all I have to do is select these faces. I can select these faces individually. However, if you have a lot of faces to select, you may not want to select those individually. So if you want to use a window selection, you can go into class selection, and then you have some other options, filter options and things like that as well. So now I'm able to use the window selection. Okay. And now I'm going to go ahead and specify the tool. Again, I'm just going to use a 0.5 millimeter. And we'll set our roughing to 0 and just do one finish pass for now. And we need to specify the height again. I'll check this part as well. I think it's 30 millimeters as well. Yes. So we'll input 30. All right, all that looks good. Okay, so let's take a look at 4-axis internal trim. We'll go ahead and generate this. Again, it automatically picks a start location. So we'll go into verify. Take a look. So notice that the tool is along the angle of the pocket. Okay, so now what we'll do is the same way that we did on 2-axis, we can do the same thing in 4-axis. We'll go ahead and specify some control points. Let's do a threaded hole. Maybe our threaded hole is down here at this location. We'll go ahead and do 150 and 30. And then we'll do our lead-in point centered on that edge. And we'll go ahead and turn on our roughing passes. Let's do 3 roughing passes. And we'll generate that. So again, now you see the roughing passes and then that final finish pass. Now we have our thread hole location and then our lead-in location. Again, this works basically the same way as the 2-axis operations. All right, so let's take a look at a part that's going to require 4-axis external operation. All right, as you can see here, this part has tapered faces as well. Some are straight, some are tapered. So these here are straight, and then the rest have a taper shape. So I'm going to specify the part. And I'll go ahead and create an operation. So this is going to be external trim. Now for specifying geometry on this, again I'm going to use 4-axis and then use side faces. I'm going to go into class selection. Now I can pick these individually. I could probably try to do a window selection as well, but what I want to show you is Notice I have multiple faces around the outside of here, so it may take you a while to pick those. A little shortcut would be to pick just the top and the bottom, and then actually just use invert selection. So that will invert the selection. So instead of picking the top and the bottom, it will select everything else for you. So a little shortcut there that may save you a little bit of time. So now we've picked our faces around the outside of the part. Specify the tool. And we'll go ahead and leave roughing passes. We'll leave that set to the default. In cutting parameters, again, I need to specify the height of the part. So this part is 20 millimeters tall. We're going to go ahead and leave the defaults here, except for change this to tangent 2, and go ahead and generate this. Now notice we have a cutoff distance here. And we'll go ahead and verify this. Okay, so that looks good. So as you can see, the external trim with 4 axes basically works the same way as internal. You have the same type of settings that we looked at for internal trim. Now let's take a look at one other part that I have here. Okay, what you'll notice on this part is it has basically a straight face here. This is vertical, and then we have tapered faces here. So in order to cut this, we can actually just use 2 different type of operations. We can cut the straight face and then the angled face as well. Go ahead and define my workpiece. Go ahead and create an operation. This is going to be an open profile. And I'll go ahead and use the 2-axis option for now. I'm going to use the curve option and then chaining. And I'll go from the right side over to the left. And I'll go ahead and use the same diameter wire that I've been using. All right, and we also need to set that upper limit. So I'll go ahead and measure this part in the Z direction from top to bottom, and that is 10.16. And I'm not going to do any rough passes. I'm just going to do one finish pass here. And in verification, you can see that the wire stays straight or vertical and just cuts that straight edge or vertical edge. So then the next thing that we can do is we can actually use 4-axis and then go along this tapered edge. So I'm going to do open profile again, use the same tool. Now when I go into my geometry selection, I'm going to use 4-axis, and then I'm going to go ahead and pick the faces that we need to cut. That looks good. Now in cutting parameters, I need to set that value again, 10.16. I'm going to use tangent 2 on my wire position. And just do one finished pass. So notice what it does is it projects this angle face down to the Z0 level, down to that lower guide. So we can see that in verification here. So notice the wire is along this angle. So even if you don't have a full, complete tapered surface, you could still achieve the cutting conditions that you need to cut a 4-axis tapered shape like this. Okay. Well, that's all the time that we have for this session of Lunch Bites. I hope today's session was informative for those of you that haven't done Wire EDM programming before, and I hope for those of you that have done Wire EDM programming, maybe you were able to pick up on some shortcuts or tips along the way. If you have any questions about today's Lunch Bite session, please email those to me at chad.varney@allyplm.com. I want to encourage you to go to our website at www.allyplm.com and check out our current NX training options. We offer a 1-week Essentials for NX Designers class. We also offer a 1-week NX CAM Fundamentals class. Also, these classes are taught here in our Cincinnati, Ohio location, and they're also taught online. Also, I want to mention that we're offering a free GoPro camera if you sign up for our select training classes, and those training classes that I just mentioned are in this current promotion. This offer is good through August, so please check out our website for details. I want to thank you all for joining us. Hope you have a great day.